As many as 10,000 people in this country die each year as a result of burn-related infections. That's because if you suffer a third-degree burn, the most severe, damage extends through every layer of skin. And without that protective covering, the body's open to infection, which can lead to sepsis. And skin that devastated is not able to regenerate because the cells needed for repair have been destroyed. Skin grafts can help, but there are limitations. Now there's hope on the horizon. Tonight I investigate the 3D skin being developed at RPI. In May 2013, Sapphire Terry was the sole survivor of a house fire in Schenectady that claimed much of her family. The capital region prayed for her survival and cheered as she healed from burns over most of her body. We love you, Nico! 3 years later, in October 2016, there were prayers for 16-year-old Nico DeNovo, extensively burned following a devastating car accident, but tears almost a year and a half later when he succumbed to his injuries. Surviving extensive burns to the body is perilous because skin, our largest organ, protects the rest of our body from infection. When it's compromised, we're at risk for sepsis. Grafting skin onto the burned area requires surgically taking skin from another part of the body. But skin grafts often shrink, and taking skin from another body part means skin in that area has to regrow. Moreover, if a patient is burned extensively, there may not be enough skin to graft, and grafts grown in the lab are rudimentary, not nearly as complex as our skin is. Enter the work of a research team at RPI, headed by Associate Professor Dr. Pankaj Karande, dedicated to finding a way to 3D print skin.
And so, of course, printing anything that's going to be a living tissue, a living organ, is far more difficult.
More difficult than the solid objects we've come to associate with 3D printing, like limbs and tools. Dr. Karande's team looked to biology for a blueprint to assemble the right ingredients, including stem cells and nutrients. Human skin, discarded during surgery, provides those raw materials.
And what we do is we combine them into inks. We call them bioinks, and we fill up the cartridges of that printer with these bioinks, which have the proteins, the growth factors, cells, and then we print them. We start arranging them in a layer-by-layer fashion, depending upon which cells go where in that particular tissue.
And once they cleared the first hurdle, keeping the cells alive during the stress of printing, it was on to the next challenge, making the product more complex, in short, more like skin, a major step beyond current skin graft material created in the lab.
But it's very simplistic. It does not have some of the more complex features like hair follicles, for example, sweat glands.
Incremental steps of increasing complexity is how Karande describes the ongoing work. And as they tackle those challenges, they also must overcome graft rejection because the body will see it as something foreign, the same issue faced with any kind of organ transplant.
One way we are doing that, and this is our work with our collaborators at Yale, is thinking about how to edit those cells so they do not have the specific immune markers, so we can construct a skin graft that's more universal and can be pre-made before the patient arrives in the clinic.
Karande's work was started almost 9 years ago, and it's anyone's guess how much longer will be needed. None of the studies done with the 3D printed skin so far has been done in humans, but Karande says results are encouraging. The product they've created doesn't shrink as much as current skin grafts, which is key to mobility. So imagine, as Karande does, these 3D printed sheets of skin ready to be used to help burn victims like Sapphire and Nico heal, survive, and thrive. And while the work is encouraging, there's no timetable as to when the 3D printed skin grafts will be available.